Hello everyone, so in this video we want to determine the direction of polarity of the indicated bond in the following compounds using the symbols of delta plus and delta minus. So the ability of an atom to attract the shared pair of electrons towards itself is what we call electronegatiivity. Polarity in covalent bonds arises as a difference in electronegativities of the bonded atoms. The difference in electronegativities result in the separation of charge, creating what we call a dipole moment. So the more electronegative atom can attract the shared pair of electrons more strongly, generating a partial negative charge on itself, while the less electronegative atom develops a partial positive charge. In our first molecule here, between the fluorine and iodine, fluorine has an electronegativity value of 4.0, so let's actually write this data out. So fluorine has a value being 4.0. So for these values here, it can either be found online, given to you by a professor, or even found in your textbook. So again, these are just values that I have. So again, fluorine has an electronegativity value of 4.0. Iodine here has a value of 2.5. And oxygen has a electronegativity value of 3.5. So now using this information for the molecules, again, we're doing A first. We'll do all of that in red color. So we have fluorine and iodine. All right, so like we said, fluorine has a value of 4.0, which is more electronegative than the iodine, which has a value of 2.5. So the fluorine develops a partial negative charge, so delta minus. And then iodine, of course, by default, will have a delta plus or a slightly positive charge. And our second molecule here, we can go ahead and do everything in this green color. We have our hydroxide and then a fluorine group. So in our second molecule, fluorine again has a 4.0 electronegativity value, which is more electronegative than our oxygen, which has a value of 3.5. So oxygen then does develop a partial positive charge, so delta plus, and fluorine develops a partial negative charge, so delta minus. So that's how we can go ahead and determine the direction of polarity of the indicated bond in the following compounds using our delta plus and delta negative symbols. So go ahead and highlight this. So this in highlight is going to be my final answer for this problem.